36 summation as n goes from 0 to infinity, 7 to the n plus 3 to the n, all over 6 to the n plus 4 to the n. So I didn't write this portion down, but let's have some intuition. As n keeps getting bigger, so as n approaches infinity, the top, the 7 to the n will dominate. 7 to the n will grow so much faster than 3 to the n ever could. So we can just consider 7 to the n. Similarly, on the bottom, 6 to the n will dominate. So this will behave very similarly to 7 over 6 to the n. And that's a 7 to the n over 6 to n, sorry, which is 7 over 6 in parentheses to n. That's a geometric series with r equals 7 over 6, which is greater than 1. So this is going to diverge. And actually, what I just did is the spirit of the limit comparison test. Well, I'll go over more in detail of that in the next problem, number 37, but let's keep that in mind. Okay, so this is probably going to diverge. So, and actually, with that intuition, we can use the test for divergence, actually. Okay. So, limit as n goes to infinity of this guy. The hard part for using the test for divergence is you can't really use L'Hopital's rule here because imagine you keep taking derivatives, right? Things will never go away. So you got to do a different technique to evaluate this limit, which is the following. You can totally do this. You can factor out a 7 to the n on the top, so it becomes like this, and a 6 to the n on the bottom. It becomes like this, okay? And over here, it's just properties of exponents. You got to know your algebra, all right? So, and then now let's use properties of limits. We can break this limit up into the product of these two. Yeah. This limit, let's focus on this second one first. 3 over 7 to the n power as n goes to infinity. This will approach 0, right? Similarly, 4 over 6 to n power, this will approach 0 as well. So we have 1 over 1, which is 1. Okay. That's how I simplify that. And then this one, 7 over 6 to the n, as n approaches infinity, this will blow up to infinity. So as we expected, the series diverges by the test for divergence. And that's what I was explaining. Our intuition, as n keeps getting bigger, it's gonna behave very similarly to 7 over 6 to n. Yeah? This is the spirit for both actually the test for divergence and the limit comparison test for this one. Okay? I'll show you the limit comparison test in 37, all right? Or we can just use a direct comparison test. Here's another way to think about it. If you don't want to evaluate that limit. This is our original guy, okay? What if we change this 4 to the n to a 6 to the n? Now, is this guy bigger or smaller? It's smaller because 6 to the n is bigger than 4 to the n. We're dividing by more. When we divide by more, the final value is less. So that's why I put a less than sign here. And then we can rewrite the bottom as 2 times 6 to the n. So this guy, we can rewrite as this, okay? I put it in a summation as well because it's the series we're going to compare with. And then we can use some algebra and properties of summations to rewrite it like this over here, okay? This piece, this is a geometric series. This is also a geometric series. This part converges. R equals half over here, okay? R equals 7 over 6 over here. This is greater than 1, so it's going to diverge. This piece diverges, this whole thing is going to diverge, all right? And since this guy diverges, our guy's even bigger over here, right? Our guy's even bigger. So something bigger than something that diverges is going to for sure diverge as well. So this is another way to show that our series up here diverges. So here's two ways to go about it.